Hello, my name is Jonathan Preston. I'm an environmental engineering student at the University of Central Florida, but this summer I am taking some classes at FSEJ. One of the classes I am taking is pre-calc, and I have noticed that many of the problems that I've had deal with square functions. Square functions can be complicated and time-consuming. However, if you have the basic intuition to deal with them, you can get rid of them quickly. This is the most simple square function, y equals x squared. Its vertex, or the lowest or highest point of the function, is at the origin 0, 0. And it's reflected across the y-axis. It opens up, and its y-intercept is 0, and its x-intercept is 0. The first thing you need to look for when you see a square function is which way it opens up. That is dictated by if it has a negative symbol in front of the x function. What is plotted right now is the basic x function. It opens up and has its intercept and vertex at 0, 0. Y-intercept, since it is negative, will be the exact same thing, just flipped over the x-axis. So its point will be negative 1, 1, 2, negative 4, and it will just be flipped over the y-axis, since the axis of symmetry is the y-axis. So it will be at negative 1, 1 and negative 2, 4. The next thing you need to look for when solving a square function is stretches and compressions. These are dictated by numbers in front of the x value. Numbers greater than 1 dictate a stretch, which increases the y value for the plot. Compressions, which are dictated by numbers less than 1, shrink the plot and making it wider. The first plot is y equals 2x. It'll still open up, and because it does not have a vertical horizontal shift, its vertex will be at 0, 0, and since it has a 2 in front of it, its y value will be twice as usual. So instead of being at 1, 1, its plot would be at 1, 2. Instead of being at 2, 4, the next point would be 2, 8. And because its axis symmetry is the y-axis, each of the points is reflected over, giving you the square function's shape. The third thing you look for is horizontal shifts. Horizontal shifts are dictated by numbers that are inside the parentheses and not outside of the square. So, the first point here is y equals x plus 3 squared. Contrary to popular belief, you would think normally that a positive number would cause a shift towards the positive side of the Cartesian plane. However, it moves it to the negative side. So a positive 3 would act like a negative 3. So instead of having the vertex at 0, 0, the vertex would be at negative 3, 0. Since it does not have any vertical or compression or shift factors to it, it'll just be plotted as a standard square function. So instead of being at 1, 1, its first value would be at negative 2, 1. Instead of being at 2, negative 4, its value would be at negative 1, 4. And since it is not over the y-axis, it actually reflected over negative 3. So you can plot the points at negative 4, 1 and negative 5, 4. This will give you the standard shape of the square function. final one is a vertical shift. Vertical shifts are dictated by having a plus or minus number after the square. And these simply move the function up or down. The function x squared minus 3 is going to move down 3. So instead of being at 0, 0, it will be at 0, negative 3. It will be just like the square function and where its x values are, so it will be at at 1, negative 2, and at 2, negative 1, 2, 1. And it is reflected over the y-axis, giving it the standard square value shape. Square functions are not held only in pre-calculus classes. They are held in many other college level math classes. Hopefully, now that you have the basic intuition to plot such functions, you will be able to save some time and effort on tests.